Okay, here's our final part of the solution. We found a solution for A. Now we have to find a solution for B. Now we're going to use the fact that A is 300 minus 290 e to the minus 3t over 100. So what we're going to do is we're going to plug that in for A right where we have it, and that's going to mean B prime is 3 over 100 times 300 minus 290 e to the minus 3t over 100 minus 3 over 80 times b. Now, because we solved for a and plugged it in, this is no longer two unknowns. Previously, this equation had two unknowns. It had a and b as dependent variables and unknowns, and that's not the case anymore. Now that we've plugged it in, we have a single differential equation remaining with one unknown, which is b. So we're going to write that as b prime plus 3 over 80 times b equals, look at this right-hand side. So looks like 9, that's 3 times 3, 100 divided by 100, minus 3 times 290 divided by 100, e to the minus 3t over 100. Whatever that combination of stuff comes out to be there, we'll leave it like that for now. So that's a first order linear constant coefficient differential equation. We could use Mach, but I'm going to use integrating factors because because I'm more comfortable with it. So we're going to e to the 3t over 80 is our integrating factor. We multiply everything through by that, and we have on the left-hand side b times e to the 3t over 80 quantity prime. And on the right-hand side, we're going to have a 9e to the 3t over 80 minus 3 times 29 over 10. Cancel the 0 there. Times e to the minus 3t over 100 plus 3t over 80. Multiplying those exponentials together is going to work like that. All right, so I got to integrate both sides. I integrate both sides. I have b e to the 3t over 80 equals 9 times 80 over 3 e to the 3t over 80. All right, I guess we do have to do some work on this. So let's deal with that right there and figure out what the common denominator is there. So let's see, that would be minus 3. I'm going to multiply this by 80 plus 3 times 100 times t over 80 times 100. Maybe not the smallest common denominator, maybe it is, but that definitely works. So that looks like t times negative 240 plus 300 over 8,000. And that is 60t over 8,000, which is 6t over 800, which is 3t over 400. And that seems like as far as we could go there. All right. So that means that the integral there is going to give us a minus 3 times 29 over 10 times 400 over 3 times e to the 3t over 400. Woo! All right, that was a lot of work. And we now solve for b, and b equals 9 times 80 over 3 plus c, constant of integration. Can't forget that. And then we have minus 3 times 29 over 10 times 400 over 3 times e to the 3t over 400 minus 3t over 80. And then finally, that goes on the c, so plus c e to the minus 3t over 80. And that is our solution, and it's, kind of unpleasant. We can do a little bit of canceling of things now. So b, so it looks like a 240, and the next term I'll cancel that, and I'll cancel that, and who knows what 29 times 40 is, but I'm going to leave it. So times 29 times 40 e to the 3t over 400 minus 3t over 80 plus c e to the minus 3t over 80. And there's our solution. We, at this point, just have to solve for c, and we do know that b of 0 equals 5, so that's going to be 240 minus 29 times 40 plus c, and so c is going to equal 29 times 40 plus 5 minus 240. So that's going to be our c, and we can plug that in when we got it. So you see it's not easy, right? And I happened to pick numbers that ended up being somewhat ugly, but algebra aside, this is doable. We had to solve for a because the a equation allowed us to solve for a. It didn't have any b's in it. Once we had a, we could plug that into the b equation, and then the b equation became something that we could handle and deal with, even if it was a little bit ugly.